Welcome, fellow Round Rock ISD first grade teachers. I am absolutely thrilled to be your instructional coach today. We are going to get you completely and confidently prepped for Grade 1, Unit 2, Objects and Matter. Whether you're a first-year teacher or a seasoned veteran looking for a quick refresher, this explainer is designed exactly for you.
So grab a coffee, get comfortable, and just take a deep breath. We're going to unpack absolutely everything you need for this unit in a quick peer-to-peer overview that totally respects your busy schedule. You know, you really don't need a heavy science background to teach this well. You just need the right roadmap, and we've got it right here.
Here's our exact roadmap for today. Number 1, Unit TEKS and Student Mastery. 2, Core Science Concepts. 3, Common Misconceptions. 4, Investigations and Mods. And 5, Vocabulary and the Interactive Word Wall.
All right, Section 1, Unit TEKS and Mastery, the destination. Let's dive right in and look at exactly where we're taking our students by beginning with the end in mind.
So we're targeting 3 specific science TEKS here. First, 1.6a, where students classify objects by physical properties. You know, things like shape, color, texture, size, and weight. Next is 1.6b, which asks students to explain and predict changes caused by heating and cooling. And finally, 1.6c, where students must demonstrate that a whole object is actually a system made of organized parts.
Now you might be wondering, what does student mastery actually look like on your report card rubric by the end of this unit? Well, it basically means a student can classify a set of objects by one property and then independently resort that exact same pile by another property, all while using descriptive academic language. They should also be able to explain how pieces form a whole and accurately predict what happens when materials are heated or cooled.
Moving right along to Section 2, Core Science Concepts, the Terrain. Let's quickly translate the foundational science you need to feel totally confident teaching this unit, and hey, no advanced degree required.
The foundational pillar for this unit is that physical properties are simply anything we can observe with our senses. This includes relative scale, comparing size and weight using everyday terms like larger, smaller, heavier, and lighter. Essentially, if a student can look at it, touch it, or weigh it on a balance, it's a physical property.
Next up, our students need to understand that objects aren't always just solid, singular blocks. Things like toys, bicycles, and puzzles are systems. And a system is simply built from specific, organized parts working together. It's like a giant puzzle, really. If you take the parts away, the system changes.
Finally, we teach changes in matter. We do this by showing that heating and cooling are active, observable processes that literally change materials. Sometimes these changes are completely reversible, like, say, melting chocolate into a liquid and then cooling it right back down into a solid.
All right, on to Section 3, Common Misconceptions, the potholes. What's really fascinating here is that even adults sometimes hold these common misconceptions, so we need to be incredibly vigilant. Our first major pothole is the assumption that big automatically means heavy. I mean, first graders naturally assume a giant object weighs more than a tiny one, right? We're going to completely bust this myth by letting them physically compare a large, lightweight beach ball with a much smaller, heavier tennis ball using a pan balance.
The next misconception is all about shapes. When you ask a first grader about a shape, they usually default straight to math class: triangle, circle, square. But we need to help them expand their science vocabulary so they realize that shape is a broader physical property used for classification. We want them describing things as round, flat, bumpy, or irregular.
And our final misconception is a total classic. Students, and let's be honest, a lot of adults too, often think we're adding cold to an object when we cool it down. We need to strongly reinforce that cooling is actually just the removal of heat, which causes a material to harden or freeze.
Okay, Section 4, Investigations and Mods, the vehicle. Now let's walk through the hands-on 5E investigations you'll be running. This is where the magic really happens in the classroom.
In Lessons 1 and 2, your students are going to get super hands-on. In Super Sorters, they'll sort everyday classroom objects. Then, in Size Surprise, they hit 2 stations. At Station 1, they'll use ribbons to measure and order balls by size. At Station 2, they use pan balances to test weight, discovering firsthand that the biggest ball isn't always the heaviest. Such a light bulb moment. For Lessons 3 and 4, we move into Systems and Matter. In Pieces and Parts, students use 6 straws and some clay to build a system, trade it,
take it apart, and build something entirely new with those exact same parts. Then, we have the highly anticipated Change the Chocolate Lab, where they get to actually observe the melting and hardening of chocolate.
So, the absolutely crucial point for classroom management here is strictly following the Lesson 4 safety rules. The teacher, and only the teacher, handles the hot plate while wearing heat-resistant gloves. Students must observe from a safe distance, no exceptions. Also, to support your emergent bilingual students during these collaborative labs, make sure to utilize sentence frames like, I put these objects together because they are all, to ensure everyone can actively participate.
And finally, Section 5, Vocabulary and Word Wall, the tools. Let's see how we anchor everything students just did with their hands into scientific academic language.
Here are your key vocabulary words mapped out across the 4 lessons. We're connecting everything from physical properties in Lesson 1 to scale and attributes in Lesson 2, systems in Lesson 3, and material changes in Lesson 4. Now, let's look at exactly how you'll script the physical motions for these words with your class.
For Lesson 1, you'll use the sentence frame right on your word wall, I can classify objects by blank. You'll actually have your students physically model the words as they say them. So rub your hands together for texture, trace a shape in the air with your finger for shape, and point to a color in the room for color.
In Lesson 2, to teach size attributes, you'll guide them to say, a blank is larger than a blank. While speaking, they're going to spread their arms wide for larger, bring them in close together for smaller, and dip their shoulders side to side to mimic a heavy pan balance tipping for heavier and lighter.
For our Lesson 3 systems TEEs, the sentence frame is, a whole is a blank made of blank. This is modeled by interlacing your fingers together for a system, separating your hands completely to take apart, and cupping your hands together to put together.
Finally, in Lesson 4 for changes in matter, use the frame, heat causes blank to blank. Have students briskly rub their hands together to create friction for heat. Open their fists downward like dripping liquid for melt. Hug themselves and shiver for freeze, and gently fan their faces with their hands for cool.
So you've got the TEKS, the science, the lab setups, and the word wall scripts ready to go. But here's the real question to consider as you step into your classroom. When a first grader realizes that the giant beach ball is actually lighter than a tiny tennis ball, or that they can completely melt and reshape matter, how does that single moment permanently change the way they view the physical world around them? Have a fantastic time sparking that curiosity this week, and we'll see you on the next Explainer.